Hello friends, today we will learn about number systems. We will learn about irrational number, representing real numbers on the number line, real numbers and their decimal expansions, how to express real numbers in P upon Q form, visualization of real number on number line using successive magnification, operation on real numbers, how to rationalize the denominator and laws of exponent for real numbers.
We come across simple equations to be solved in mathematics. For example, the equation x plus 5 equals to 12 is solved when x is equal to 7, as this value of x satisfies the given equation. Here, the solution 7 is a natural number. Now for the equation x plus 7 is equal to 7, which is solved when x is equal to 0. If we think only natural numbers, equation 2 cannot be solved. To solve equations like number 2, we took the number 0 to the set of natural numbers and obtained the whole number sets. But whole numbers will not be enough to solve the equations like x plus 15 is equal to 7, as x is equal to minus 8. So we took positive, 0 and negative numbers in the set. Now think the equation 3x is equal to 2, which is solved when x is equal to 2 upon 3, which is not an integer or whole number. The solution 2 upon 3 is a rational number in which 2 is a numerator and 3 is denominator.
A number S is called irrational if it cannot be written in P upon Q form, where P and Q are integers and Q is not equal to 0. Real numbers. The collection of all rational numbers and irrational numbers is called the set of real numbers. It is denoted by R. A real number is either rational or irrational. Every real number is represented by a unique point on the number line. Every point on the number line represents a unique real number. So, the number line is also called the real number line. Now let us represent real numbers on the number line. Let us locate root 2 on the number line. Consider a square OXYZ with each side 1 unit in length. Now by the Pythagoras theorem, OY is equal to root 1 square plus 1 square is equal to root 1 plus 1 is equal to root 2. Now to represent root 2 on the number line, transfer figure onto the number line, making sure that vertex O coincide with 0. We have seen that OY is equal to root 2, so using a compass with center O and radius OY, draw an arc intersecting the number line at the point B. Then B corresponds to root 2 on the number line. Real numbers and their decimal expansions. When we divide the number by any number, one of three results is observed. Number 1, the remainders either become 0 after a certain stage or start repeating themselves. Number 2, the number of entries in the repeating string of remainder is less than the divisor. And number 3, if the remainders repeat, then we get repeating block of digit in the quotient. So for all rational numbers of the form P upon Q, where Q is not equal to 0, on division of P by Q, two main things happen. 1, the remainder becomes 0, or the remainder never becomes 0 and we get a repeating string of remainders. Now let us take case 1. The remainder becomes 0. Number 1, 5 upon 2 is equal to 2.5, and number 2, 34 upon 10 is equal to 3.4. In these cases, the decimal expansion terminates or stops after a certain number of steps. We call the decimal expansions of such numbers terminating. Number 2, the remainders never becomes 0. Case A, number 1, 100 divided by 3 is equal to 33.333. 1 divided by 7 is equal to 0.142857, 142857, 142857. So in case 1, 3 repeats but remainder does not become 0. And in case 2, 142857 repeats but remainder does not become 0. In these cases, the decimal expansions does not terminate or stops after a certain number of steps. We call the decimal expansion of such numbers non-terminating repeating or recurring decimal expansions. Similarly, the remainder never becomes 0 case 2, root 2 is equal to 1.414213562371309880168872420962. Too long. Similarly, 22 by 7 is also long. In case 1 and 2, no numbers are repeating and also remainder does not become 0. In these cases, the decimal expansions do not terminate or stops after a certain number of steps and also does not repeat. We call the decimal expansion of such number non-terminating, non-repeating or non-recurring decimal expansions. Now let us learn how to express real number in P upon Q form. Let us take 1.272727 ... Let x be 1.272727 ... Here 2 digits are repeating, so we multiply x by 100 to get 100x is equal to 127.27272 ... and x is equal to 1.27272 ... Now taking 1 minus 2, we get 99x is equal to 126. So x is equal to 126 divided by 99 is equal to 14 divided by 11. Now you can try the following. Let us visualize 3.685 on the number line using successive magnification. Step 1. We know that 3.685 lies between 3 and 4. So look closely at the portion of the number line between 3 and 4 and divide this into 10 equal parts and mark each point of division as in figure. Step 2. Now divide portion of the number line between 3.6 and 3.7 into 10 equal parts as in figure below. Step 3. Now divide portion of the number line between 3.68 and 3.69 into 10 equal parts as in figure below. Hence, we get 3.685 on the number line. Let us see basic operation on real numbers. Addition. Add 3 root 2 plus 6 root 3 and 4 root 2 minus 5 root 3. Here first of all we will take all this in the bracket and then we will keep root 2 together and root 3 together. So final we will get 7 root 2 plus root 3. Similarly for multiplication we will take together root 5 and root 5 will become 5 and 7 3s are 21, so 21 5s are 105. For subtraction we will take root 2 root together, that is 4 root 2 minus 3 root 2 will together and that will become root 2 and the final answer will be root 2 minus 5 root 3. For division 9 root 15 by 3 root 5 we will first divide it into 5 multiplied by 3, that is 9 root 15 is equal to 9 multiplied by root 3 multiplied by root 5. We will divide it by 3 root 5. We will get final answer 3 root 3. Now let us see how to rationalize the denominator. We will take the rationalization of the denominator of 1 upon 5 plus 2 root 3. First of all we will take the shard, that is we will take the opposite sign of the term. Suppose we have the positive sign in the denominator, we will take negative sign. So 1 upon 5 plus 2 root 3 will become 1 upon 5 plus 2 root 3 multiplied by 5 minus 2 root 3 upon 5 minus 2 root 3 will become 5 minus 2 root 3 upon 1 time plus and 1 time minus, that is 5 plus 2 root 3 and 5 minus 2 root 3. The denominator will become now 5 square minus 2 root 3 the whole square, as x plus y, x minus y is equal to x square minus y square. This is an identity. Now we will take 5 minus 2 root 3 divided by 25 minus 12, and the final answer we will get is 5 minus 2 root 3 upon 13. Let us see some laws of exponents for real numbers. Let x be greater than 0 be a real number and m and n be rational numbers. Then x raised to m dot x raised to n will be x raised to m plus n. X raised to m whole raised to n will become x raised to m multiplied by n. X raised to m divided by x raised to n will become x raised to m minus n. X raised to m y raised to m will become xy whole raised to m.
So friends, if you like my video, please like and subscribe. And if you want a suggestion on any topic for explanation, mention them in the comment section. Stay tuned for the next video. Goodbye.